Determine whether the series is absolutely convergent, conditionally convergent, or divergent. We just have the terms written out here. 1 minus the cube root of 2 plus the cube root of 3 minus the cube root of 4, and so on. All of our tests require us to have the summation form of it to know what the a sub n formula is. So on this one, we're going to have to figure it out for ourselves. We note that is alternating, starting with positive, and if this is going to be our first term, it seems like we're just taking n and taking the cube root of it. So we alternate and take the cube root. Great. Okay, well, then that's going to make our summation be negative 1 to the n plus 1 over n to the 1/3. It's n plus 1 because we're going to start this thing at 1. And we want the first one to be positive, and so 1 plus 1 is 2, negative 1 squared is positive 1. Great. So we have the summation. We're trying to decide absolutely convergent, conditionally convergent, or divergent. So the very first thing we do is consider the series with the absolute values. If this thing converges, we're done. The original series converges absolutely. So if we drop the alternating series part, that would be us taking the absolute value of all the terms, making everybody positive. But this should look familiar. This is a p series with p less than 1. So it diverges. When your series of absolute values diverges, it's not the end of the story. Go back to the original and try the alternating series test, or perhaps the test for divergence. So back to the original. Let's go with the alternating series test. It starts off by you also disregarding the alternating sign part and dealing with the sequence b sub n, 1 over n to the 1/3. Two things need to be true. The limit needs to be 0. Oh, definitely. And it needs to be decreasing. So b sub n plus 1, the next term, needs to be smaller than the previous term. And it is. Smaller denominator, same numerator. Larger denominator makes the whole fraction smaller. So we're good. Bn is decreasing. The limit 0. So by the alternating series test, the original series converges. So the series of absolute values diverges, but when you go back to the original, you get convergence. Let's then just report that this is conditional convergence. Let's go to the next slide to actually say it. We have that the series on an is divergent, but the series on the absolute values of the an's are divergent, but the series on the regular series is convergent. This is a weak convergence. It's called conditional convergence.